And now we'll move on to our last speaker, Luci. Luci, are you ready?
Thank you very much for inviting me to talk. And yeah, like you mentioned, we were really honoured and excited to be given the first place award last year in the Tech for Wildlife Challenge in the judges panel. So yeah, that was a really lovely piece of encouragement for us that what we were doing was working. And so I'm going to talk about some of the tech that we've been developing, which is looking at recording proximity and movement behaviour, but really focused on the smallest animals, or at least that was where we started, but we've ended up with much wider applications than we imagined. So first, a little bit of a background. We are predominantly, it's myself and Ivan here as well. I am a disease ecologist based at Bangor University in North Wales, with a really strong interest in understanding animal movement and behaviour and what that means for things like disease transmission and zoonotic spillover. And Ivan is an embedded systems engineer with an interest in low power solutions. He was based at the University of Antwerp, where we both were originally. We started developing the loggers in 2018. We got a grant to help us along the way in 2020, but obviously global events meant that there was some issues there with some of the work that we were doing. And we actually managed to launch a spin-off in 2022 with the loggers. So Ivan now works full-time for the loggers so that we can actually continue the development that we're doing. So really why we started doing this was because, as I'm sure most people are very, very aware, studying wild or captive animals can be really challenging. It can be very expensive. It can be extremely labour intensive, both in getting the data, but then trying to analyse it afterwards. It can be really disturbing for the animals in the process. It can end up being quite limited in spatial or temporal resolution. And these factors make it particularly challenging for the smallest animals. Plus, just finding anything you can put on a small animals can be, is challenging. And so we really looked to see whether or not technology could provide a solution for this. And we came up with these little devices, which we called ProxLogs very originally at the time. And this was actually initially Ivan's master's project. When he first started working on this. And it was basically designed for this little mouse here, Maximus natalensis, with the idea that we wanted to look at contact behaviour and disease transmission in these mice. So a big overview of the system. It's a Bluetooth-based system, so we use Bluetooth low energy to record the proximities. We have the kind of hardware parts of the system, which I'll go into a little bit more detail, but it consists of our tiny loggers, what we call stationary loggers, and a gateway. Everything is controlled through a mobile phone app, and then that gives you raw data that you can do various things with. So to dive into a little bit more detail in the mobile loggers themselves, just against this micro SD card for scale, so you can see that they are really small. The smallest ones weigh just under a gram. And they're very customizable. So you can completely customize the scheduling. And with that, that means that you can get battery life of sort of between about 4 or 5 days all the way up to 12 weeks, depending on how you customize the scheduling. The contacts are recorded based on the signal strength, and the signal strength is what's actually recorded. And you can boost the loggers if you want to extend the range of them, but that of course has a cost on the battery life. I would say the mobile loggers, they are really tiny, and they kind of have a limit of about 3 meters, like logger to logger, when you're looking at the range, unless you boost that range. So they really are about recording proximity data. The stationary loggers are a bit bigger, so they also have a much larger battery, and these record the proximity of an animal to a given environmental feature. These can be placed in a grid to assess movement as well. So you can look at where animals are moving, but you can also place these on larger animals and use them as mobile loggers. And these operate for months, depending on how you set them. And they have a much longer range. So you're looking at maybe sort of 15 meters or more. And then finally, we have a gateway which downloads the data from the loggers. It keeps all the loggers in sync by synchronizing the clock. It monitors the loggers and records the battery status, and even just records if it hears a logger. So you can decide at what point you want to download the data based on how many logs are recorded on the logger. But even if there's no logs, you still get a record of that data. And then the data is stored locally on an SD card, but we are working on an online database at the moment. So this is how, this is the mobile phone apps. This is kind of what it looks like. We have a kind of landing screen that gives you lots of information about the loggers that you can see. So it will, depending on the firmware that you're working with, it will tell you about the battery life. It will tell you about what the amount of data that's held on the loggers, whether they're scanning or whether they're advertising only. So that's if they're able to record other logs or if they're just sending out their own ID into the environment. Through that, so then you can select on one of the loggers, and this is how you basically configure them. And so you can do this at any point, even if the logger is on an animal. If you can connect with it, you can configure it, and there you can control various parameters, like whether or not you want to scan to record the contacts, whether you want to hide that logger for some reason, say if you don't want other loggers to be able to record it. You can set a hibernation mode, so your loggers are only active when your animals are active, and you can boost the range. You can also interrogate the data on the logger, so you can download the data and have a look at it through the app, but yeah, it's not the easiest way of doing it, so we would always advise having a gateway. So this is what the data looks like. We basically just get the raw data off the loggers and then say, like, it's kind of up to you for how you want to use it, but you can use it in lots of different ways. So this plot here is just from an experiment where we've been looking at the interactions between ewes and their lambs, and we're looking at their associations. And so here is just taking the raw data and putting it into a heat map, so that where the color is darker red, that kind of insinuates more time spent together by that pairing. You can also use it to make these kind of social networks. And this is really nice because, again, this is from the sheep lamb data. And although we provided no information, we just did the social network analysis based on the raw data. It correctly pulled back the right pairings there, so the right mother and offspring pairings, which is really nice. And then finally, you can see as well, like I said, you can look at the number of the interactions with something in the environment. So this is from a starling experiment that we did that I'm going to show next, but this just shows how different birds were using the feeder, so the resource in the aviary, in different ways. And so this is one of our quite early prototypes. You can see the logger here on the back of the starling. They're much smaller now than these ones. But this was just really nice because you can see, you can get a kind of temporal register of the data as well. So you can see the associations between the birds in the flock, in the social network here on the left, and also the heat map in the middle. But what we found is that it was really difficult to try and verify the loggers, because when we tried to go and observe the birds, they really didn't like humans being there. So it was really hard to know that which birds were actually contacting each other when we were trying to confirm that our loggers were working. Then we put the camera traps up, but actually most of the interesting behaviour was happening after dark, or it happened so quickly we couldn't actually tell which individuals were involved. So we were able to sort of trace that back through using the loggers, but it was a really nice verification of the extra information that you can get from using the loggers. Like I said, we are a Bluetooth-based system, so we don't really have any limits on where the loggers can be used. So this is a map of different places where the loggers are being deployed by various studies at the moment. And yeah, like I said, like they started off for our little mouse down here in Tanzania at the bottom, but now they're being used on a really wide range of species and a really wide range of studies for things I would never have imagined. So it's been really exciting to see that happen. So I wanted to then just sort of briefly finish by talking a little bit about some of the challenges that we're facing and where we would be like, yeah, really up for talking to people to see what people think. One of the challenges is how we actually attach the loggers. So we provide them without any sealants, and we say to people, like, you know your species best, but we can kind of help. But these loggers are really delicate. They are really easily damaged by humidity. This is one of my sheep here, well, a lamb with the logger, and it was sealed in Plastidip with silica beads inside heat shrink, and I still must not have done it enough because the logger failed due to humidity. So that's one of the real challenges we're facing, is how you can securely protect them without making them too heavy for using on the species we actually want to use them in. The other challenge that we are sort of thinking about now is how we actually get the most out of the data that we have collected. Because when we started this, we really had a very specific use case and kind of knew what I wanted with the data. But now we're realizing just how much data we get from it. And it would be really nice to think about how we can leverage a lot more information from that. So again, coming back to this sheep study, the ewe is logging the other loggers around her. So she's got a logger on a collar. She's logging every 10 seconds. The lambs are advertising only. So it's a very quick log rate. And what we see is in the flock of sheep that we had, the 11 sheep that we had, that was like nearly 600,000 lines of data that we started with. If we just look at one sheep, she was 40,000 lines of data, of which 30,000 were her own lambs. So, okay, we've got kind of a good amount of data to work with. But then it's kind of like, well, how can you get the best out of that data and what does it mean? Because we're interested in trying to identify the close contacts, but Bluetooth is a really, really noisy signal. And so how do you try and get that signal out of the noise? And, you know, one of the things you can do, like, is maybe you just say, okay, there's a cutoff and anything over -60, we assume is a really close contact. But then, and we say -60 because of kind of tests that we've done in the field where we see that there's quite consistently, there is close contacts if you're at, say, -60. But why not -61, for example? It just seems, yeah, sometimes I wonder, like, well, is this really the best way to think about the data? So then the other thing we've been looking at is starting to play around a bit with smoothing windows. But again, here the question is like, well, what's the best smoothing window? Are there better algorithms we could use? Are there better approaches that we could use? And yeah, like what's the meaning? And of course, all of these things will be really related to your question and kind of your study species as well, like what you want to know and what's meaningful for your question. But I think it would be really nice to try and get a bit more detail out of the data that we've got. So if you would like more information, you can visit our website. I'm also always very happy to talk about it and some of the other kind of things that we are trying to do. And I would also just like to flag up Tim Wild's lab at the Max Planck Institute as well, because they are developing some extremely cool tiny loggers that also do some quite fun things. So thank you.
Amazing. Thank you so much, Lucy. I think the whole WildLabs team was really excited to hear this specifically after seeing so many cool images from your work. So very exciting to hear. I also dropped in the link to the prox logs on the inventory on WildLabs where people can kind of leave reviews and find out more and stuff too. So it seems that we have a few questions in the chat. Brett, did you want to jump in with your question quickly?
Sure. Yeah, I just wanted to ask if you had any kind of information or background on how you guys went about handling like BLE licensing fees, or if there's like a pre-certified module you were able to use or something.
Yeah, so we are currently in the process of doing that. So we are using a pre-certified module, and I'm not the best person to ask. The engineer would be, our engineer would be the best person to ask, because it's only very recently that we've got to a point where I think we are no longer in a prototype, because at the we are basically on, I think, what I hope will be our final iteration of figuring out exactly how to get the charging to work, because that's been one of the trickiest things, to get the recharging on such a tiny device to work. If we have managed to crack that in our latest round, then yeah, we can push forward with getting all of that done, which would be really, really good.
Great, thank you. And thanks, Brett. It was great to hear about some of the challenges. I think that's always really helpful context for folks working on similar things. You also mentioned that you're working on an online database. What are some of the other kind of next steps or challenges on your way?
So we've actually been working, I was really excited to see Sarah here from the Edge Impulse platform, because we have been playing around with Edge Impulse quite a lot, actually thinking about, so we've had some master students doing some work looking at developing accelerometer and inertial-based models for welfare detection in certain species, with the link to, because we're interested in what it means when you are changing a landscape and how that changes an animal's behaviour and what that then links into disease. But we're also really trying to push forward, looking at acoustic detections as well. So yeah, how we can use this kind of edge impulse approach to create better or create useful monitors for ecosystem health, but with a kind of focusing on the species that we might be interested in for disease spillover effects.
Super exciting. All right. Well, thank you so much, Lucy. Again, we're happy to connect folks. If you'd like to learn more, chat with Lucy more, let us know. We can help that happen. All right, we are pretty much at time. We just want to say a huge thank you to all of our wonderful speakers today, Neville, David, Sarah, and Lucy. We learned a lot, and it was wonderful to hear about your work. I know these are just giving little tastes. You don't have much time to share, but you all did a wonderful job explaining what you're doing, and I think getting folks interested. Again, yeah, let us know if we can help with any follow-up, and we hope you are all going to jump in and share your awesome work in the Tech for Wildlife Challenge next week. For those of you who want to stick around, we're also going to be hanging out for after hours per usual after we stop the recording, but no pressure to stay if you have to run. So thank you so much, everyone, for joining today, and we'll see you next month.